Hi, in this video we will learn how to find the area of a triangle constructed by two vectors in R3. One thing you need to recall from the previous unit is that we know that the area of the parallelogram constructed by two vectors u and v in R3 is equal to, so when you have two vectors u and v, you can construct a parallelogram just by drawing up parallel lines like that. The area of that parallelogram, now we know that is equal to the length of u cross v. Very nice. Now, to find the area of the triangle, the area of the triangle constructed by u and v is equal. So to see that what is happening here, you just need to know this very simple fact that, well, if someone gives me u and v, yes, that will create a triangle, this triangle here. But that triangle is actually just half of the parallelogram constructed by u and v. Well, just consider this piece here, and that triangle is the same, has the same triangle as this one. So that means that the area of the triangle is equal to half of the area of the parallelogram generated by u and v. So that means that this is equal to half of the length of u cross v. And that is the new formula, or the formula that we want to know and use for this video. Okay, if someone asks for the area of the triangle constructed by two vectors, you just need to find the cross product, its length, and half of that is the area of the triangle. Let's do some examples here. So example, find the area of the triangle. Well, there are two triangles. We have to do two different examples. Part one is that constructed by vectors -3, 0, -1, and 2, 1, and 0. Part two, this is another triangle with vertices given by 3 points, 1, 0, -1. This is P. Q is 2, 1, 1. And the third one is 1, 3, and 2. Okay, let's try to do the first one. Solution for the first one. Okay, these are two vectors. Let's call one u, one v. So we know that the area is equal to half of the length of, not the cross product, but its length. -3, 0, -1 cross 2, 1, 0. You may ask what order I should put. You can put either. The point is that the cross product, if you change the order, will be different, but the length you will get is the same thing. So then this means that I have to first find the cross product. What is the vector obtained by this? This has three components: -3, -3, 0, -1, and 2, 1, 0. The first component, you ignore the first column. The remaining is a 2 by 2 matrix. 0, -1, 1, 0. Find the determinant of that. Then ignore the second column. The remaining is again the 2 by 2 matrix. It is -3, -1, 2, and 0. Multiply that by negative sign. And the third one, ignore the column 3 and find the determinant of the remaining matrix. So -3, 0, 2, 1. We know that the determinant of 2 by 2 matrix is product of the diagonal elements minus the product of diagonal elements. Here there's a negative sign. You have to remember that one. In the middle component you have a negative sign of the determinant, so it will be -3 times 0 minus -2 times 1. And for the third one we have -3 times 1 minus 0 times 2. Okay, this computations and now is easy. This is 1. The second one is -2, and the third one is -3. So we have two a vector. Now we need to find its length and divide it by 2. The length of 1, -2, -3 is equal to, we know how to find the length. Square each component and then add them. Then find the square root. So this is half of square root of 1 plus 4 plus 9. Those add up to 14. So we have root 14 over 2. That is the area of the triangle in part 1. How about part 2? In part 2, in part 2, we don't have two vectors. Instead, we have 3 points, which makes sense, yes, but a triangle can be given by its vertices. So here P, Q, and R, it forms a triangle. What you need to notice here is that, well, okay, if I have P and Q and P and R, for each one I can make this directed line segment and this directed line segment, yes? Then for each directed line segment, I can find one unique vector which is equivalent to that. So for PQ, I find U. For PR, I can find V. And then the triangle they form is the same thing. Well, this tells me everything. So first you find equivalent vectors. So find vectors u and v. While u is equivalent to pq, it means what? It means that its components are given by the coordinates of the endpoint here is q 2, 1, 1 minus coordinates of p 1, 0 and negative 1, and that gives me 1, 1 and 2. How about v? Well, the endpoint of v is r, so we have to write the coordinates of r 1, 3 and 2 minus the coordinates of starting point, which is p 1, 0, negative 1, and that gives us 0, 3 and 3. Yeah, well, very good. Now we have two vectors we can find. Second step is that we need to find the cross product. Yes, find u cross v. It means that I have to find 1, 1, 2 cross 0, 3, 3. And this is a vector with 3 components. And how do we find that? Put 1, 1, 2 in the first row, 0, 3, 3 in the second one. Then ignore the first column. The remaining is a 2 by 2, 1, 2, 3, 3 matrix. Find determinant of that. For the second one, ignore the second column. Then the remaining is a 2 by 2 matrix, 1, 2, 0, 3 multiplied by negative sign. For the third one, ignore the third column, and the remaining is a 2 by 2 matrix, 1, 1, 0, 3. Okay, so we find now the determinant. Diagonal elements, 1 times 3 is 3 minus 2 times 3 is 6, negative 1 times 3 is 3 minus 0, and 1 times 3 is 3 minus again 0. So this gives us negative 3, negative 3 and 3. This is u cross v. Now it is time to find the area, because we have the cross product and then the area. Find the area. The area is half of u cross v, which in this case is this vector negative 3, negative 3 and 3. Find its length and then divide it by 2. It is half of negative 3 squared, negative 3 squared, and then 3 squared, then add them. This gives us half of 9 plus 9 plus 9. Well, this is half of 27, so this is root 20, 27 divided by 2. You can simplify a little bit. I'm not expecting you to be able to do this, but if you can, this is perfect. This is 3 root 3 over 2. What we learned here is just one formula, that the area of a triangle constructed by 2 vectors in R3 is equal to half of the length of the cross product of those 2 vectors, and we did 2 examples.